How are you? Today I am going to discuss one important question which came in December 2020. The correct statement for the following for the orientation of bromine atom in the most stable conformation of A and B. So in A and B, first we have to draw this in Csir conformation, and we will flip the ring and we will see the interactions operate in these two compounds. So if we take the compound A, we will designate the carbon as 1, 2, 3. Now we'll draw the Csir conformation. Let's say this is 1, 2, 3. So in 1 it is in above the plane, and in 3 it is above the plane, and the bromine is below the plane. And if we flip the ring, then we'll have this axial group in equatorial position and the equatorial group in axial position. This is 1, 2, 3. In 1 and 3, the two methyl group will go axial position. So two methyl group will go in axial position, and the Br which was in axial, it will go in equatorial position at position 3. Now we will see the interactions operate in these two conformation. Here one hydrogen is there, and here also one hydrogen is there. So this hydrogen Br 1,3 sign diaxial interaction will operate, and this Br and hydrogen another 1,3 sign diaxial interaction will operate. So two sign diaxial interaction, and in this compound the two methyl group is in axial. So between these two sign diaxial interaction will operate, and here also hydrogen is there. This hydrogen methyl another two sign diaxial interaction will operate. So here total 3 sign diaxial interaction. So this compound is unstable, and this compound is unstable, and this is more stable. So the equilibrium will shift towards left. So in A, the Br will be in axial. And if we take the compound B and will number this as 1, 2, 3, 4, and now we'll draw it in Csir conformation. The methyl group 1, 2, 3, 4 is below the plane, and in 2 it is above the plane. In 4 the Br is above the plane. So all the three group is in axial. If we flip the ring, the methyl will go into equatorial. Here it will also go into equatorial, and the Br will go equatorial. So here all the group is in equatorial position. So you can see that here more 1,3 sign diaxial interaction will operate, and due to this here total 5 1,3 sign diaxial interaction will operate, and due to this the equilibrium will shift towards right, and the compound B, the bromine will be in equatorial. So the Br will be axial in A and equatorial in B. So this answer is correct. So if you have any doubt regarding this video, please let me know in comment box. The correct order of carbonyl stretching frequency of the following compound. So we have to consider here the hybridization of this carbonyl carbon atom. So this is sp2 hybridized, and this is sp hybridized, and this is also sp2 hybridized. But here the in this case it is quite different. It has to make the 3-member ring possible, it has to increase the p character into these orbitals, and it has to increase the s character into this carbonyl group. So here the s character is 33% in normal sp2, In SP it is 55%. Yes, sorry, 50%. And in this compound, the S character of the orbital will be greater than 33% and will be less than 50%. Now, higher the S character of orbital, lower the bond distance, and lower the bond distance, higher the stretching frequency. So higher the S characters, lower the bond distance, and lower the bond distance, higher the stretching frequency. So the S character order for A, B and C is B greater than A greater than C. So the stretching frequency order will be B greater than A greater than C. This is the S character order and this is the stretching frequency order. So the answer B greater than A greater than C, B greater than A greater than C, this is the correct answer. So guys, if you have any doubt regarding this video, please let me know in comment box. Question: the correct order of pK of the following compound. So guys, here the three compounds. This is a very easy question. This is a cyclopropene, this is cyclopentadiene, cycloheptatrine. Now here we have to notice that they want the correct order of pK value, not the acidity. The order of acidity is the reverse of the order of pK, because the higher the acidity, lower the pK value, and the weaker the acid, higher the pK value. That means acidity higher means pK lower. Now between these three compounds, if we take the conjugate base of these three, this is A prime, this is B prime, and this is C prime, the conjugate base of A, B and C. Now A, this is a 4-pi electronic system, cyclic planar conjugated, so this is an anti-aromatic anion, whereas the B prime, this is a 6-pi electronic system, cyclic planar conjugated system, so this is an aromatic anion. And the compound, the anion C prime, which is 8-pi electronic system, and this is also cyclic planar and conjugated, this is also anti-aromatic. So as the B prime is aromatic, so the dissociation, that means the equilibrium of this kind will be much favorable for this compound, and the acidity of B will be higher than the acidity of B will be higher than A and C, and consequently the pK will be lowest for B. And between these four options, the B is lowest in this option, so this option is correct. Guys, if you have any doubt regarding this video, please let me know in comment box.